All right, so it's 1 o'clock. I guess we'll get going here. I see that Sebastian's admitted everybody from the waiting room that was waiting. So welcome to our second online learning session from the McCrone Research Institute. Today we're going to be talking about dispersion staining, and specifically I'm going to focus on central stop dispersion staining. So as we go through today's presentation, I'll give you a little bit of an overview about dispersion staining. Then I'll show you how to set it up on the microscope. And then towards the end, what I'll do is show you how to make your own central stop dispersion staining objective. And then we will install it onto the microscope that I've got here today. So as you can see behind me, my backdrop today is a central stop dispersion staining image. So this sample is a mixture of glass, and these glass particles are mounted in 1.520 high dispersion liquid. And if you look at this, you see that there's color that appears around the edges of our particle. So dispersion staining is a method of optical staining. So it sounds like you're going to be staining your sample with some sort of dye or probe, like in histology or fluorescence microscopy. But that's not actually what we're doing. We're staining our sample with light. So we're making a few adjustments to our microscope. We're using a single polarizing filter oriented in the east-west orientation. And then of course, we're using a central stop dispersion staining objective. So color appears around the edges of our particles due to the refraction of light at the particle boundary. So again, we're only going to see color around the edges of our particle, not really all the way through the center. So let me just make sure we've got a good internet connection and things seem to be going okay. So let's get going. I wanted to go through a few things. I have a brief PowerPoint presentation, and then we'll go on with setting up our microscope and making our central stop dispersion staining objective. So let me share my screen with you. All right, there we go. So again, talking about dispersion staining today, and specifically we'll be dealing with traditional dispersion staining using a central stop dispersion staining objective. Just to get started with a little bit of background about me, I know I've had some of you, I recognize some names. I've had some of you in class. I've met many of you at Intermicro. But for those of you that haven't met me, I'm a staff member here at the McCrone Research Institute. I have been here since 2007, so quite a few years now. Before I came to the McCrone Research Institute, I studied chemistry and microbiology at the National University of Ireland in Galway. I am a native Chicago resident, so while I was home throughout the summers, I had the opportunity to meet Skip Palahniuk, and he was the one who told me about the McCrone Research Institute and recommended that I actually come and take a class here. So while I was a college student over the summer, I came and took a class at the McCrone Research Institute. So my very first polarized light microscopy class was taught by John Deli. And it was a really interesting week. I enjoyed every moment of it. And whenever I had the opportunity throughout college and beyond, I came back and took classes at the McCrone Research Institute. When I finished up college, I actually worked out in one of the suburbs of Chicago, but I always kept my eye on the Institute because I was always interested in what was going on there. And when a job opportunity came up, I certainly jumped at the chance. And like I said, I've been here since 2007. One of the resources that's available for you is a Tricks of the Trade article. So this article was published in the Microscope Journal back in 2009. And in this Tricks of the Trade article, there's good directions on how to make your own central stop dispersion staining objective. So there have been lots of things written about making dispersion staining objectives, but I thought it would be nice today to actually demonstrate the step-by-step procedure and maybe some of the pitfalls that you might come across into making one of them. So this article is available on our website as a free download. So please have a look at our website and take advantage of that. Some other resources that we've made available, again, if you go to our website, we've put up a lot of articles and free resources there. Again, you can print some things as PDFs, and there's also links to YouTube videos. We've put up a lot of YouTube videos recently. In fact, there's a really good one that's a nice complement to what we're doing today. It's a video done by Dr. McCrone on the study of minerals using dispersion staining microscopy. So I would certainly recommend having a look at that video on YouTube. It's quite good. So dispersion staining is a really targeted approach for looking at samples. Again, it's a rapid method to determine the presence or absence of a given material. So it works very well if you know exactly what you're looking for. If you have something that's an absolute complete unknown, this maybe isn't the technique to begin with. It might be something that you eventually get to. But again, this works really well if you know what you're looking for. That's why it's very commonly employed in asbestos analysis. In fact, I would say it's probably the cornerstone of asbestos identification. If you're trying to differentiate the different varieties of asbestos, this is certainly one of the techniques that should be used in every lab to analyze it. And it works really well for it because asbestos minerals have been very well characterized over the years. So people know exactly what they're looking for. They know exactly what the refractive indices of these asbestiform minerals are. So that makes it lend itself really well to dispersion staining. But I would say that asbestos is certainly not the only type of sample that you would use with dispersion staining. Dispersion staining can be a really powerful general screening tool. So let's say you worked in maybe a pharmaceutical lab and you had bulk material that was coming in as part of the production. If there was maybe a contaminant that you wanted to be able to screen for very rapidly, this technique would work quite well for that. So when we're talking about dispersion staining, these two images here are kind of really the starting point for why we see the colors that we do with dispersion staining. If you look over here at this image on the left-hand side, what we've got drawn here are two dispersion curves. One for a solid, which we see here, and the solid could be the particle that you're interested in, and a second curve for a liquid. So the liquid can be your mounting media. So when we're looking at what's occurring here, we have a few items that are marked in on this dispersion curve. So we're looking at the relationship between the refractive index of your particle, of the mounting media, and then we're also looking at wavelength as well. So we have here over on this side, lambda 1 or wavelength 1. And if we're looking here, we can see that the refractive index of our solid is less than the refractive index of the liquid. If we head all the way over here at what we're calling wavelength 2, the refractive index of the liquid is less than the refractive index of our solid. But what's important about what we see here is this one, lambda 0 or wavelength 0. Some may also refer to this as the match point. And when we have a nice sharp intersection between the dispersion curve of our solid and our mounting media, this is what gives rise to the colors that we see with dispersion staining. And again, we see these colors appearing at the edge of our particles because of the refraction of light that's occurring at the particle boundaries. So this is what we're looking for. Always a nice sharp intersection. And I should point out that this sharp intersection between the solid and the liquid, it needs to occur within the visible spectrum. So typically the visible spectrum is considered between about 400 and 700 nanometers. So this has to be a color that we are able to see. Today, we're going to be talking about traditional dispersion staining. And with dispersion staining, there are two types of objective that are commonly employed. There's an annular stop dispersion staining objective, With an annular stop dispersion staining objective, what's been modified within that objective is that an opaque disc is set inside the back focal plane of the objective. And what happens is that this disc allows some light to travel through the center of the objective, and all of the other light is blocked out. And I'll explain a little bit more on that in some of the coming slides. On the right-hand side, this is a representation of central stop dispersion staining. With central stop dispersion staining, there's an opaque disc in the center of the objective in the back focal plane. And in this representation here, this opaque disc is held in place by some pins. So some models of dispersion staining objective, this is a piece of metal or plastic that's held in place with pins that are adjustable to enable you to adjust the position of this stop and ensure that it's centered. Now, the big difference between annular stop dispersion staining and central stop dispersion staining really is the colors that you see. So with annular stop dispersion staining, that small opening within the center of the objective, that allows light of the matching wavelength to travel through it. With central stop dispersion staining, the color of light that is the matching wavelength, that is actually what is blocked out, and then we see a complementary color to the matching wavelength. Now, here's the difference between what you would see with these two types of dispersion staining. With annular stop dispersion staining, we see colored particles on a white background, and with central stop dispersion staining, we see colored particles on a black background. So if we have a look here in this annular stop image, we see in the center there are some particles that are green. And green would be the matching wavelength here. Now, if we look at the exact same image with central stop dispersion staining, those very same particles are now magenta. And that's because magenta is the complementary color to green. So that's why we see those colors. So this color compensating triangle shows you what you would see. If green were the matching wavelength, of course, your particles would appear magenta. So with central stop dispersion staining, we're always looking at complementary colors. Now again, when we're setting up things for central stop dispersion staining, the type of objective I'm going to show you how to make is one of these. And again, it blocks out light traveling through the center of the objective, or basically that matching wavelength of light. When you're doing dispersion staining, there's dispersion staining charts that have been created that are certainly very helpful to keep at your side when you're working in dispersion staining. So this is the McCrone dispersion staining color chart. This also is available for download from our website. And if we look at this chart, there are two bars of color, one for annular stop and one for central stop. So of course today we're really going to be focusing on central stop. And when you look at this, the colors on any of these charts really should just be used as a ballpark for your colors. So if you start to see yellow on your particles, you should always then go to the word descriptions written on these charts, and that's where you get that more precise wavelength. So you're able to assign a numerical value to the color that you're seeing. So again, no matter what, use these colors to get you in the general range, but when you're looking for precision, you certainly want to go for the word descriptions of those colors. I have a few images I wanted to show you as well of central stop dispersion staining. So over here on the left-hand side, this is the amosite variety of asbestos, and this is mounted in 1.680 high dispersion liquid. So if you had a sample that you suspected may contain amosite, if it was mounted specifically in 1.680 high dispersion liquid, and you saw your fibers, or fiber bundles, I should say, were golden yellow parallel, and a nice royal blue perpendicular, then that's indicative of amosite asbestos. Another variety of asbestos here, this is chrysotile mounted in 1.550 high dispersion liquid. And for chrysotile, we would expect to see magenta in the parallel orientation and blue in the perpendicular orientation. So dispersion staining works well provided that you are mounted in a mounting media that's very close to or matching the refractive index of your particle or fibers of interest. So we would not be seeing these colors if this amosite sample were mounted in a different refractive index liquid. We specifically see these colors in 1.680 liquid. And for chrysotile, we're specifically seeing these colors in 1.550 liquid. And while we're here looking at the fact that I'm mentioning that we have high dispersion liquids, let me show you what I mean. There are two different types of refractive index liquids. And for our refractive index liquids, let's make sure you're able to see what I've got here. Okay, there we go. So there's two different types of liquid. There's standard refractive index liquids and high dispersion liquids. These high dispersion liquids will actually tend to give you brighter, more vibrant colors. So those would be the ones I would recommend for dispersion staining specifically. Okay. So let's get back to the PowerPoint presentation I had. I just wanted to make sure I showed you the difference between those liquids. Okay. There we go. So here's the dispersion staining chart. And with this chart, again, another one, we made it available on our website. This is just a blank chart. You'll notice that this is log paper. So this enables you to do straight line plots. If you're trying to characterize something with dispersion staining, this is certainly a good resource to use in the beginning. And there's where I mentioned that you can use a standard or a high dispersion liquid. And the high dispersion liquids will tend to give you more vibrant dispersion staining colors. Here's an example of a dispersion staining plot for sodium chloride. So let's say sodium chloride was a common contaminant that you wanted to be able to have a nice quick screening tool for. So what was done here was sodium chloride was mounted in 3 different refractive index liquids. It was first mounted in 1.540 liquid. You see that plotted here. Color was observed. In this case, the person saw red. It was then mounted in 1.544 refractive index liquid. This person saw blue, and then in a separate liquid, it was mounted and they saw a light blue. So now you know if you need to screen for sodium chloride, if you went and mounted it up in any of these 3 liquids and looked for the specific color that you had associated with that. So in this case, if you mounted it up in 1.542 refractive index liquid and saw red, you would know that those were your sodium chloride particles. So here's an example of what something like that might look like. Again, you can use it as a quick tool to tell whether you have something that's heterogeneous or homogeneous. So if this happened to be a mixture of sodium chloride and something else, we would know that if this was in our 1.542 liquid, any of our red particles, those would be our sodium chloride. So to set up your microscope for dispersion staining, there's a few things that we need to pay attention to. First and foremost, I've highlighted it here in yellow. Your microscope needs to be set up in curler to begin with. That means everything within the light path throughout your microscope needs to be correctly aligned. Okay. If that hasn't happened before you begin setting things up for dispersion staining, things are unlikely to work out well for you. So this must be done first. I've already set my microscope up here, up in curler, so we're kind of ready to go in that respect. So the next step for setting up dispersion staining is that the central stop within that objective needs to be centered. And it needs to be centered within the condenser aperture. So if we look at this image over here on the right, here's our central stop, and surrounding it is our condenser aperture. And we can see that the stop is not well centered with respect to the condenser aperture. What we would want to do is adjust things, and that would be adjusting the position of this central stop to be centered as well as possible within that condenser aperture. Once that's centered, the condenser aperture then needs to be closed just behind that central stop. So it's closed down quite a bit. It'll be closed down even further than what you see in this image here. And one of the last steps here is the top lens of your condenser needs to be removed. So if you do have a condenser that has a top lens, so I've got one here because you won't be able to see it on my microscope when I go to it. So this top lens, if you have one that's removable, you're going to want to take it out. That's the last position. And then of course, the condenser aperture, you'll be adjusting that and you'll be closing it down almost all the way. So once we've taken that top lens out of our condenser, the other thing for dispersion staining is this is one of those times where you probably will need to turn up the voltage, turn up the light intensity on your microscope quite a bit, and that will help improve your dispersion staining colors. So what I'd like to do now is I have a factory-made dispersion staining objective on the microscope that's sitting next to me. So I'm going to go through the setup on this microscope, and then after that, I'll show you how to make one of the dispersion staining objectives, and then I'll install it on this microscope. So let's switch over to my microscope here. Okay, so as we start out here on my microscope, you'll see probably not the greatest image to begin with. It's a little yellow looking, but we're not quite set up in dispersion staining just yet. I mentioned that one of the first things we want to do is check on that central stop within our objective. And the only way for us to do that is going to be to look into the back focal plane. So on my microscope, let me show you how to see this guy here. Oops. Let me make sure we get this out of the way here. Okay, so on my microscope over here, I've got a Bertrand lens, and this Bertrand lens, if I swing that into position, that's going to allow us to look at the back focal plane within the light path of our microscope. So I'm going to put that in. If you don't have a Bertrand lens, the alternative is going to be to remove one of these eyepieces and then just look down the eye tube. But for me, I've got a Bertrand lens. So let me share my screen here so you're able to see what I am seeing. Okay, so I'm going to put my Bertrand lens in so that we'll be looking at the back focal plane. So what you should be able to see is a central stop. This one is adjustable, so it's actually held in place by 2 pins. And what I want to do is see how well centered is this stop with respect to my condenser aperture. So if I start to close the condenser aperture, adjust that so you can see a little better. If I start to close this, it looks like it's reasonably well centered. It could be a little better. This one is adjustable. So let's see if I can make that any better than it is. So I want to get this reasonably well centered. It doesn't have to be perfect, although of course perfection is always nice. This I think should be good enough. So that looks pretty well centered. with respect to my condenser aperture. And then what I'm going to do is close this down just behind that central stop. And then I'm going to remove my Bertrand lens. We don't need that anymore. So things still aren't looking that great. I'm not seeing a black background yet and color around the edges of my particles, but that's because I'm not done setting things up. So one thing that needs to happen is that top lens needs to come out of my condenser, and then I'm going to need to turn up the light intensity here. And what we should start to see is a nice black background and color around the edges of my particles. And that's what we've got here. This is actually a sample of the mineral olivine. So olivine is a biaxial mineral. So because it's biaxial, we know that that means it has 3 different refractive indices. So actually, as I rotate the stage, we actually should see that the color should change on some of these particles as the orientation changes. So when you're setting up dispersion staining, the key things that you want to look for are that you have a nice black background and color along the edges of your particles, okay? So one thing that people starting off when you're familiar with polarized light microscopy and then you start doing dispersion staining, one thing that people often accidentally superimpose is crossed polars at the same time. And this is certainly, that's not going to work. This is different. So dispersion staining, you have a black background and color around the edges of your particles, but it is absolutely not caused by crossing your polars. So that's an easy thing to accidentally mix up. So that's certainly a pitfall I would recommend just keeping in the back of your mind so you don't accidentally make a mistake on that one. So this microscope looks like it's set up pretty well for dispersion staining. So that's on my nice factory installed dispersion staining objective. So what I'd like to do now is go over how we would make a dispersion staining objective. So let me switch back over here. Okay. That over. So I'll show you how to make 2 types of central stop dispersion staining objective. On the left-hand side here, this one was made using electrical tape. And you can see in this image, we have a small spot of electrical tape. In the center here, there are 2 pieces of double-sided tape. And the double-sided tape is what's holding down the cover slip that this central stop is sitting on. On the right-hand side, this is a central stop dispersion staining objective made using liquid correction fluid. So both of these work as long as whatever material you use for that central stop is opaque, you'll be okay. If you're doing it with correction fluid, sometimes you may need to make, to do 2 or 3 layers of correction fluid to make sure, because sometimes when it dries, it can crack a little bit. So you may need to add an extra layer of correction fluid. Okay, so to make your central stop dispersion staining objective, there's really just a few simple supplies. Of course, you need a spare 10 times objective. I like to use round cover slips. So these circular cover slips, my preferred size would be 18 millimeters. Double-sided tape, razor blade. If you're using black electrical tape, of course, you'd want to have that, or some liquid correction fluid, some type of hole punch, and forceps as well to be able to move things around. And I just want to make sure that I also make sure people are aware of some things that we need to pay attention to with dispersion staining. Of course, getting that stop centered is really important, and making sure that you have a well-prepared sample. So I say here, watch out for tilted cover slips. So when you're preparing a sample, you really want to make sure that the entire area underneath that cover slip is filled with liquid. You'll probably have to turn up your light intensity, and of course, everything needs to be very clean. I can't stress that enough. If you end up having fingerprints on your cover slips or get drops of refractive index liquid on top of your cover slip, this can obscure things that you're trying to see. if you need to, sometimes closing the field diaphragm a little bit can be helpful as well. So let's get going with actually making one of these central stop dispersion staining objectives. So here's my workstation. You can certainly purchase factory-made dispersion staining objectives. So all of the major microscope manufacturers are likely to sell one. And usually they're pretty decent, but they can be expensive, some of them. This is just a really inexpensive way to make your own, especially if it's just a technique that you might just want to try out before you incorporate it into large-scale analysis. I would say that I have seen the occasional factory-made dispersion staining objective where that central stop has been made too small. So that means that when you go to close down your condenser aperture, it can't close behind that central stop. And if it's too small, really there's very little that you can do with it. So if we go over and have a look, I've got some spare 10 times objectives, a selection of cover slips. Of course, we'll be using round ones. I've got electrical tape, hole punch, and I use a plastic slide to punch them out. So you can use a traditional hole punch. However, a lot of times these make a spot that is a little bit too large. This one here ends up with about a 6 millimeter spot, and those are a little bit too big, at least for the systems that I've tried. Again, your microscope, there's always going to be some amount of trial and error. So it's a possibility. What I've got here, this is from a set of hole punches, so they come in various different sizes. So I'm actually using the smallest one of that set. I've used one of these as well. These have a selection of different sizes. This one works quite well. So you'll just have to see what you've got. And then of course, there's correction fluid as well. So I'm gonna start off, I'll show you how to set up with the correction fluid one, and then we'll go and make the electrical tape stop. And the electrical tape stop, I would say that's my preferred method, but both of them work. So let me get a few of these items out of the way. So if you're going to make a stop with correction fluid, what I would certainly recommend, first of all, is the style that uses the brush applicator. Many of the ones that are made now actually have a foam wedge applicator, and it's really hard to get a round spot from a wedge-shaped applicator. So you can try, you might be able to get something, but these are better. The other thing that a lot of people have are these correction fluid pens, and you may or may not have success with these. I really haven't had success. The reason being is that you have to push down and apply pressure to get that correction fluid to come out. And then what happens is very often you'll just snap that cover slip. So if you're using one of these, I would certainly recommend starting with a square cover slip just to practice, and make sure that you're able to get one of those nice round spots. So if we're having a look at this, in fact, let me just adjust things so you can see a little bit better. Oops. And we'll zoom in so you guys can see. There we go. So with these correction fluid stops, again, of course, give your liquid a good shake, and then I would recommend trying a couple of them to make sure that you're able to get a good round spot. And I just say that because sometimes round cover slips, they might be in short supply, but these square ones, you have plenty of them. So make sure you can get a good, decent stop. And then once you're sure you can do that, certainly start on your round ones. And I would also recommend when you're making these, make several. Don't just make one, because you may not have the spot size correct the first time. So if we try and make one here, of course, that first one I didn't even get a very round spot. So you need to make several of varying different sizes. And then before you start to install them into your objective, of course, make sure that it's fully cured. I've also had success. I used some black quick drying nail polish that actually seemed to work okay as well, or some sort of black enamel paint, but the correction fluid works nicely. So I would certainly make several of those, because there's always going to be some amount of trial and error. Okay, so let's head back over here. So that's how you make them. Again, it's not that complicated, but I wanted to show you how to make them in my preferred way, which is going to be using electrical tape. So what I've got to begin with is I have my electrical tape. I took the liberty of putting some on a plastic slide. And if you put it on a plastic slide, that means you have a nice soft cutting surface for it, because I'll be using one of these hole punches. So I've got a plastic slide, and my electrical tape is already on there. And then the second thing we need is just a little bit of double-sided tape. So there's a little bit of double-sided tape that I put onto just a standard glass slide. And I need the double-sided tape so that I can use it to fix my round cover slip inside my objective. So let me at least try and get a decent spot here. So with these, again, you have to apply, at least on my set, a good amount of pressure to get it to cut all the way through. You can always tap one of these with a rubber mallet. I won't do that on screen for the sake of everybody's ears. But if we have a look here, let's see if I was able to cut this all the way through. And again, I like to just keep a razor blade handy just to try and pick this up here. And it looks like that one's okay. And again, electrical tape, whoops, and I tore that one. So that one isn't going to be great. But we'll just carefully tease these off. And I have a few that I made earlier. Yeah, that one's definitely not going to work. So we'll head back over here. We'll make another one. And again, decent amount of pressure. And we'll see if this one turns out any better. And you can see as I try and tease this one off, I have ones that I made with hole punches, and those actually didn't turn out very well because they kept cutting off a portion of it and leaving like a chunk missing. So you definitely want to make sure you end up with a good round spot. So let's see if we can get this one working. And we'll try and lift that guy off. That one worked a little bit better. Okay, so we'll pop this over. What I usually like to keep at hand is a ruler, and I put a whole bunch of different spots on them. And then I'm able to select which size is better. So if we have a look at this one I just cut, I would say it's probably not the prettiest spot that I've ever cut. But if we have a look here, in fact, let me zoom in so you guys are able to see a little bit better. Move that over. So there's the one I just cut. It's a little rough. So if I were making a dispersion staining objective, if I was making a new one, I probably wouldn't choose this spot. It's a little too rough looking, but some of these are better. And this one ended up being round about 4 millimeters. I have some that are certainly larger and some that are smaller. So you want to make a selection to see what works best. So if I'm making one of these, I have a spot ready to go. But the next thing is that I'm going to need to get my objective ready. So I've got 2 objectives here. And I will show you that one of these is designed for an infinity corrected optic system. I found that it works just as well in an infinity corrected optic system as it does in a system that uses a fixed mechanical tube length. So I've had success on both of them. The difference with these two really is how your round cover slip is going to fit in there. If we have a look at this one here on the left-hand side, and I show you the cover slip, this cover slip, there's actually, if we drop that in place, actually I'll bring it, oops, sorry for the noise there. I'll bring it over here so you're able to see a little bit better. If we have a look in here, there's a lot of extra room around here, certainly easy for this to slide around. So that's why we need to install a little bit of tape to hold that in position. If you have a look at this objective here, this one, if we add the cover slip is the same diameter as that barrel opening. So that will stay there, but you have to be careful when you're installing it. I would say for this one, what I would want to use is a little bit of tape still in here. You might need to roll up the piece of tape and then put the cover slip, just so that it doesn't slide off when you're trying to install it, and then you end up with a bunch of broken glass that falls inside your objective. So let me show you how to work these guys, and we'll get our tape cut and ready to go. So I've got my small piece of double-sided tape. And with our double-sided tape, we don't need pieces that are terribly long. So I'm gonna slice that, and I'll make a few cuts here so we can have some nice slender strips. And then what I'll do is I'll just go along this with the edge of a razor blade just to loosen those up and make them easier to pick up. So the next step is just pick off a small piece of tape and come over here. In fact, let me just move this box there so you're able to see a little bit better. And I'll apply one piece of tape here. Oops, let's see if we can grab a better hold of that. So one small piece of tape here, and let me get a second strip of tape. And we'll apply that to the other side. So once you've got those two pieces of tape there, then you can add your cover slip in. I like to put the cover slip in first, so that's held in position, because sometimes it's hard to place this absolutely perfectly. And I would then recommend taking one of your stops. So we'll grab one of these smaller ones. And then, to the best of your ability, you want to center that on to the cover slip. And the nice thing about using electrical tape is if you find that that stop is not centered, it's very easy to just peel that off and reposition it without having to pull up the whole cover slip. So that's why I would say this is my preferred method. If you had done it with a one of the correction fluid ones, you'd have to try and reposition the whole cover slip. So that's why I would say that I recommend this technique instead. Okay. So I've made one of these. What I wanted to do is install it on my microscope, and you guys can have a look, and we'll see what the dispersion staining images look like. Okay, so let's head over here. whenever you're going to install an objective onto a microscope, hopefully it goes without saying, but you definitely always want to make sure that you're holding these with two hands, just in case it slips out of position. You certainly wouldn't want to drop it. So we'll put this in position. And then again, very carefully screw that in. Okay. And if we now head over and have a look at what we see with dispersion staining. There we go. So if we head over here, this is the dispersion staining objective that I just made. And let me show you what it looks like in the back focal plane. So this stop, I would say, it's not perfect. It's probably going to be good enough. I saw that we had some pretty decent looking colors. If I wanted to be a perfectionist, I would take this off and then I would reposition that spot. It probably might take a couple of times until you get it just right. But since I can close that condenser aperture behind my central stop, and if we have a look over here, we are able to get a black background and color on those particles. So here's the one I made. If I switch back, this is actually the factory made one. So there's not a whole lot of difference between these two objectives. I have a couple of other samples, but if we have a look, just because I'm sure there's a lot of people who do asbestos analysis, I've got one here of amosite asbestos. And if we have a look here, we can see that we've got our golden yellow parallel and our blue perpendicular. So that's amosite mounted in 1.680 high dispersion liquid. And I actually did make one other slide. I made up a mixture of glass, and oftentimes many glasses tend to have refractive indices that are quite close to one another. Oh, let's see if we can get this a little bit better for you and adjust things. And if we have a look at these, you should be able to see relatively easily that we've got three different dispersion staining colors on these glasses, indicating that we've got three different glasses. Okay, so as far as what I had for you today, that's pretty much it. So we had, again, a brief overview of dispersion staining, showed you how to set up your microscope and then make one of these objectives. So hopefully you all got something useful out of it. If you have any questions, we'll try to answer them to the best of our ability. If you had questions while we're going through things, I'm sure Dr. Gary Laughlin and Sebastian Sparenga were there to answer things. And of course, my email address is readily available. You're always welcome to contact me or any of the staff members here for help with anything microscopy related. If you have questions specifically about this presentation, certainly let us know. Okay, does anybody have any questions? I'm looking here. I know somebody was looking for the diameter of the cover slip, which we had. Yes, those were 18 millimeter. Actually, I should show you. In a pinch, I was at home and I did not have a round cover slip, and I was actually able to make one with a square one as well. So if you didn't have a round one, I was able to cut that down and fit it inside the barrel. I rolled up some tape there, and that seemed to work. I think the circular ones are better, but really in a pinch, you could use one of those as well. Great, well, hopefully everybody got something about it. I'll give you guys time to filter out. I'm not seeing any. I think most of the questions actually got addressed by Gary and Sebastian. Someone asked with for the round circles with the correction fluid, could you use a stencil? I mean, you could. I haven't tried. It's certainly worth a try. But what I would say is definitely make a variety of them because there's guaranteed that you will have some amount of trial and error with it, but certainly you could try with a stencil. And hopefully everybody's able to get the dispersion staining charts from our website. If you're printing them, I would say certainly try and print them with the best quality color printer you can, but don't forget the word descriptions are really important when you're trying to be precise with your wavelength determination. Okay. Great, well, I hope that we'll see you all again soon. Also, if you have any suggestions for future online learning sessions, we're always open to suggestion. And more importantly, we are very much looking forward to the day where we can welcome all of our students back at the Institute. So that's certainly something that we're hoping will happen very soon. Yeah, someone asked about removing the blue filter on your microscope. I have found that that can be helpful. What actually can be really helpful also is closing your field diaphragm a little. So ordinarily, of course, we close the condenser aperture down, but sometimes closing the field diaphragm down a little bit, that can be helpful as well. All right, well, I think we're good. So without further ado, I guess I'll let everybody start filtering out. And again, contact me if there's anything specific. I'll give you a few minutes.
Favorite diameter for the circles?
Oh, the diameter for these. Let's see, let me head back over. Let me share the screen. Somebody had a question about the diameter for and let me okay, so I made these in a bunch of different sizes. The diameter, I wouldn't necessarily say my favorite. I would say the one that has been the most useful in the ones that I have installed it in has been usually about a 3 to 4 millimeter spot size. So if this one were a little bit nicer shaped, this would probably be my first choice. Sometimes something smaller can work better. These are really small. Here's about a 2.5 or a 2 millimeter diameter. Those may work as well. Again, it's a little bit of trial and error, but I have found that the ones that you get with a standard punch, those are a little too big, at least on the standard punch that I have. So 5 or 6 millimeter tends to be a little bit large. But again, trial and error. It's only a little bit of electrical tape and a few moments of your time. So hopefully that helps. Yeah, and definitely centering things is important. If your microscope, first of all, is not set up in curler, that's going to set you up for problems. And then taking the time to get that stop centered, you know, that'll take you a few minutes, but it's not something that's going to take hours and hours. So again, a few minutes here or there, and you should have it done pretty well. And dispersion staining, somebody asked is it good for opaque materials? No. Dispersion staining is designed for transparent materials. So things that have refractive indices, okay? Light has to be able to pass through your material. If light can't pass through your material, we're not gonna be able to get dispersion staining color. So it's only for transparent materials. Someone asked about it working for glass contaminants in food. I would think that it certainly could be used for that. Certainly you would need to be mounted in the refractive index liquid close to that of the specific type of glass that you're looking for. Glass has varying different chemistries, and that can account for changes in refractive index. So if there's a specific type of glass you're looking for, certainly you want to make sure that you're mounted in the appropriate refractive index liquid for that one. Okay. All right, well, I hope everybody has a nice weekend and is staying safe and healthy. And unless anything else pops up, I'll be ending the meeting here in another minute or so. Okay. All right, great. Well, again, have an awesome weekend. It is nice to see a lot of familiar faces, and certainly feel free to contact us at any point if you have any questions. And again, thank you from the McCrone Research Institute. Bye, everyone.